Okay, for tonight's video, I am doing problem number 9 from section 3.7, which says use implicit differentiation to find first derivative dy over dx and the second derivative d2y over d should be d2x. And they give us the equation of 4x squared plus y squared equals 4. So this is using implicit differentiation, and so how we do that is we write it out as following. Just kind of like the normal derivative, except instead of just doing it, I'm going to write out these terms for it. So I'm going to find the derivative, which is the d over dx of 4x squared plus the derivative d over dx of y squared equal to the derivative d over dx of 4. And when we evaluate that, so this is d over dx. So things that have the value of x in it, we can do them as we normally do the derivative. So 4x squared, we know the derivative of that is just 8x. Plus, and then these are not the same, so I'm going to write this, I'm going to do the chain rule. So I'm going to have because when we have something squared, we bring that number, the coefficient down. So we have 2 times y times the derivative of y. So I write that as dy over dx equal to the derivative of 4 is just 0. The derivative of any number coefficient is 0. So then when I solve this, my next step is to get the dy over dx on one side and everything else on the other. So I have 2y dy over dx equal to a negative 8x. Then to get this by itself, I'm going to divide by 2y, so that cancels. So if dy over dx is equal to negative 8x over 2y, which we can simplify down a little bit more and divide each term by 2. So we get a negative 4x all over y when we take the 2 out of the 8 and the 2 out of the 2. So this is our first derivative. So this is the dy over dx. Now we need to find d2y over d2x, so the second derivative. And I'm going to use a new sheet and then rewrite this. So dy over dx was equal to a negative 4x all over y. And when we see that we have a quotient here, we have a numerator and denominator, so we're going to use our quotient rule when finding the derivative, which the quotient rule is the u prime v minus u v prime all over v squared. So as I set that up kind of the same way using these terms of the d over dx, I'm going to write, so I'm going to have the d over dx of negative 4x. Remember this part right here, I'll just rewrite this up here. This is the u, negative 4x is the u, and the y is the v, so it's the u over the v. So d over dx negative 4x times just the v, so times y, minus u, so minus 4x, or negative 4x, times v prime, which we know that is going to be the dy over dx, just as so, and then all over v squared, so all over y squared. And when I simplify this down, the derivative of a negative 4x is just a negative 4 times y, so negative 4y. And then I have minus, again, my negative 4x dy over dx all over y squared. And when we're looking at this part, then we can move it over, again, because of the two negatives, and make it a negative 4y plus 4x dy over dx all over y squared. And in the first step, we had then isolated the dy over dx variable and solved for that. And so I made that mistake the first time going through this because we actually know the dy over dx because we solved for it in the previous problem, which was the negative 4x over y. So we can just plug that right into this. So I'll move this up. And I'll rewrite our equation. We have the negative 4y plus 4x dy all over dx all over y squared. And we know that dy over dx is equal to a negative 4x all over y. Now we substitute that in. So we get negative 4y plus 4x dy dx, negative 4x over y all over y squared. Which then when we simplify this down, we get negative 4y minus 16x squared. 4x times a negative 4x is minus a 16x squared all over y squared. And I want to get rid of that y squared in the denominator, so I'm just going to times it, the whole thing by 1, all over y squared to get rid of that. Which then I'm left with a negative 4y minus 16x squared, and then y times y squared. When we add the exponents, we get y cubed. And so our second derivative is a negative 4y minus 16x squared all over y cubed. And our first derivative was the negative 4x over y, and that is how you solve problem number 9 from 3.7.